Smooth curves are everywhere. Animation, robotics, car design, even medical imaging. But hidden beneath every B-spline is a secret system of knots, weights, and recursive cooperation. Let's enter the hidden machinery that creates smooth geometry. The spline does not move directly through space. Instead, it travels through a hidden parameter world called TTT space. The knot vector acts like a timeline, controlling where influence begins and ends. These control points do not directly form the curve. Instead, they wait to influence nearby regions. Each point becomes part of a local cooperation system. The simplest basis functions are only on or off. Each one activates inside a small knot interval. At this stage, the system is still rigid and block-like. Now the recursion begins. Neighboring basis functions smoothly blend together. Sharp blocks transform into smooth influence hills. This recursive blending is the heart of B-splines. The parameter traveler reaches t equals 1.5. Most basis functions become 0. Only nearby influences remain active. The spline now focuses on one local neighborhood. The active basis functions generate a weight vector. These weights determine how strongly each nearby control point contributes. Most distant points contribute nothing at all. The spline computes a weighted average of the nearby control points. The local influences cooperate together to create one smooth curve point. As the parameter moves continuously, the weights evolve smoothly. The local influence window slides across the control points. The weighted averages trace the full B-spline curve. The mathematician finally understands. A B-spline is not drawn directly. It emerges from recursive blending, local influence, and evolving weight vectors. Smooth global structure emerges from local mathematical cooperation.